Okay, always after we learn to integrate and differentiate a new thing, then we want to do an applications of it where we're finding areas and stuff. Okay, so just one question. Find where the hyperbola xy equals 2 meets the line x plus y equals 3. Ooh, what are we doing here? Because it's simultaneous equations. Yeah. Okay, so equation 1, I'm going to get the y by itself. So y equals 2 over x. That's going to be my equation 1. This one here can be my equation 2. And I'm going to sub equation 1 into equation 2. So that will mean I have x plus, instead of y, the y is being replaced with 2 over x equals 3. Okay, solve for x. What should I do first? Times by x. So it'll be x squared plus 2 equals 3x. Then move everything to the left. It's a quadratic. So we have x squared minus 3x plus 2 equals 0. I can factorize. What are my numbers? Minus 2 and minus 1. Okay, so null factor says x equals 2 or x equals 1. Now, if I'm doing simultaneous equations, I also want to find the y values. So maybe just over here, let's just go points of intersection. The first point of intersection was x equals 2. The y value, let's sub it into there. 2 over 2 makes 1. So it's going to be 2 comma 1. Okay, the second one, x was 1. So 2 over 1 is 2. All right, so I have found my points of intersection. Part B, sketch. All right, hyperbola. The xy equals 2 is a hyperbola. Hopefully you all identified that. It's in the first and, actually I'll make that a bit steeper. First and third quadrant. Okay. All right. The x plus y equals 3 is a straight line. Yes? We don't really need to. Let's use the points of intersection instead rather than try and find gradients and stuff. Okay? So we know the points of intersection are at 1, 2, and 2, 1. So my line is going to be coming down like that. My y-intercept, it's not very good scale here. If x is equal to 0, y is equal to 3. So that intercept there would be 3. And if y is equal to 0, x is equal to 3 as well. So that's the one that looks a bit bad. A bit too close. But that'd be a 3 there as well. Not that we really needed that, but just putting the details in. Okay, so there is my sketch. Part C. Find the area of the region between the two curves. This tiny little slither in here. Find the area in exact form and then correct to 3 decimal places. How do we find area between two curves? Upper minus lower, good. So area equals, okay, I'm integrating between where and where? 1, 2. So going to the x-axis, my intercepts were at 1 and 2, so 1 and 2. The top curve is the line. What am I putting in there for the equation of the line? No, the line is this one up here. X, what? 3 minus x, because it's got to be in y equals form, right? So this is y equals 3 minus x. Okay, so we're integrating 3 minus x. Then I subtract the hyperbola in y equals form, which was, we already did that one up the top, it was 2 over x. Line minus hyperbola, dot dx. Okay, so integrating, square brackets, integral of 3 is 3x. Integral of minus x is minus x squared over 2. Ooh, integrating the fraction. Logarithm. The 2, it shouldn't be a 2, should it? So that we need a 1 on the top. So the 2 slides out the front, minus 2 ln of x. Is everyone okay with that? Close square brackets between 1 and 2. So now, anytime you are integrating fractions, it's not always, but a lot of the time, you've got to be thinking logarithms from now on. Okay? All right. Subbing in. 3 times 2 minus 2 squared over 2 minus 2 ln of 2. All right, then subtract, sub in the 1. 3 times 1 minus 1 squared over 1 minus 2 ln of 1. What does all that stuff equal? 6 minus 2 squared over 2 is 2 minus 2 ln 2 minus 3 times 1 is 3 plus a half. What's 2 ln of 1? 0. ln of 1 is always 0. Okay? So, all the numbers. 6 minus 2 minus 3 plus a half. 1.5 or 3 over 2. And then minus 2 ln 2. Okay, so that would be the area exactly. So units squared. But then it says, and then also correct in 3 decimal places. So you type it in your calculator and you should get 0.114, correct? All right, we are done.